In Part 4 of Lecture 10, we discuss file protection. When we are dealing with personal property left in public places, we are concerned with its protection. We don't want anyone to take it, and we don't want anyone to mess with it. In the physical world, we usually do this by locking things up, or by watching it, or by setting alarms. In cyberspace, it's not so simple. While we could lock up our disks, this makes it harder to use them without physically placing them in the drive before we use them. And for remote systems, this is usually not a viable option. But there are ways that we can protect our files. We can control access by having the system limit who can access them. We can create access lists and groups which accomplish the same thing, or by requiring passwords. Controlled access means that we establish for a file a set of rights that other users may have. These can be, for example, reading, writing, executing, appending, or deleting the file. It can even include listing it as part of the directory's contents. We then grant these rights selectively to the file's owner and to others. How we define who the others are is something we will talk about in a few moments. The others can be broken into a few categories. It might include a particular group whose privileges may be greater than most other users on the system. Or it can include several such groups. Or maybe no one other than the user has rights to it. One way to implement this is to establish lists of users who belong to such groups. The only problem is that this can be cumbersome. What most systems use is a classification of users into three categories: the owner, the owner's group, and the rest of the universe. This allows us to set apart people to whom the owner will extend certain rights without it getting too cumbersome. A look at a so-called long listing of a UNIX directory gives you a good idea as to how UNIX implements protection. At the far left of each line, you'll see the protection scheme for the file. The dash at the beginning indicates that it is a regular file. The D at the left indicates that it is a directory. The other letters or dashes break down into three groups of three. The first triplet indicates whether or not the file's owner has given him or herself read, write, and or execute permission. The second triplet indicates whether any of these permissions have been given to the owner's group. The last triplet indicates whether these permissions have been given to the rest of the users on the system. How do you know who the owner is? Look in the third column. There's his or her username, RMS. How do you know what group he's part of? Look just to the right of it. He or she is part of the faculty group. In this example, the owner of the file hello.c has read, write, and execute permission. His group has read and write permission, but not execute. And the rest of the universe has only read permission. Password protection is another way of controlling file access. IBM's VM-CMS operating system allows 3 passwords per volume and 1 per file. If several users are all reading the same file at once, that's not a problem. But if one of them makes a change in the file, that's another story. What image of the file do the other users see? The one before the change, or the one after the change? Consistency semantics specify the rules by which we handle this problem. One such rule might be the one UNIX uses, where users who already have the file open will see the results of write operations immediately. Immutable shared files provide another approach to this problem. Once a file is declared as shared by its creators, no changes are allowed. This is fairly simple to implement and makes the file read-only for all practical purposes.